Hi everyone, welcome to Tara Academy. Today we are going to discuss about matrices part 3, and the content that is left over for this particular video is about eigenvalues and eigenvectors. So, what is an eigenvalue and what is an eigenvector? Eigenvalue is nothing but, let us consider a matrix A of size n by n, precisely which is a square matrix. Then there exists a non-zero vector which is said to be a characteristic vector of A such that it satisfies an equation as Ax is equal to lambda x, such that where x is a characteristic vector or eigenvector and lambda is the eigenvalue, and the eigenvalue represents the amount of expansion in the corresponding dimension of eigenvector. And what is an eigenvector? Eigenvector is nothing but it is a non-zero vector mapped by the linear transformation of the matrix A in vector space. That is what called as eigenvector, and the eigenvalues can be distinct, non-distinct, 0 or non-zero. And for every square matrix there exists a unique value of eigenvector and eigenvalue. Let us find a solution for this particular problem of matrix A which is of size 3 by 3. And things that which we have to find out in this particular problem is that we have to find out eigenvalues and eigenvectors of this particular matrix. So to find out the eigenvalues and eigenvectors, first initially we have to find the characteristic vector of matrix A, which can be written in the form of det of A minus lambda I and should be equated to 0. Then the det of A minus lambda I is nothing but 3 minus 2 minus 5, 4 minus 1 minus 5 minus 2 minus 1, 3 minus lambda 0 0 0 lambda 0 0 0 lambda. So the resultant equation of a matrix A which gives you a characteristic vector is that 3 minus lambda minus 2 minus 5 4 minus 1 minus lambda minus 5 minus 2 minus 1 3 minus lambda. So this is a required characteristic vector of A. Now to find out the eigenvalue, this particular characteristic vector will be equating it to 0. Then the det of this characteristic vector will be written as 3 minus lambda into, so for this particular matrix is the minor. Okay, so we'll be multiplying it. The resultant will be lambda square plus 3 lambda plus lambda into a cofactor. This will be minus, so minus of minus plus 2 into, for this one the minor matrix will be 4 minus 5 minus 2 3 minus lambda. So 4 into 3 minus lambda gives you 12 minus 4 lambda minus 10 into minus 5 into minor matrix will be this one. Okay, so 4 into minus 1 minus 4 minus 2 minus 2 lambda. This should be equated to 0. So the resultant, by solving this, the resultant equation which we derive is that minus lambda cube minus lambda square plus 16 lambda minus 20 equal to 0. Now to find out the vectors of this particular characteristic vector, simple that to find out the eigenvalues, we have to do a trial and error method for lambda cube minus lambda square plus 16 lambda minus 20 equal to 0. The trial and error method, first of all we will be trying it with lambda is equal to 1. It should be satisfying this particular equation. So let us substitute 1 in this equation. So minus 1 plus 16 minus 20, which is definitely not equal to 0. Let us try with lambda is equal to 2. Implies 2 cube, that is minus 8 here, minus 4 plus 32 minus 20. As you can see, this minus will give you minus 32 and plus 32, that is equal to 0. So here we can understand that lambda is equal to 2 is a factor of this particular characteristic equation. Then that means that lambda minus 2 are into, there will be one certain equation. Let us consider x. So we have to find out this particular x and should be equated to 0 in order to find out eigenvalues. So by factorization method we will find out how. Okay. So lambda minus 2 into minus lambda cube minus lambda square plus 16 lambda minus 20. We will be equating this and we will be dividing it through factorization method. Here let us multiply this with lambda square minus lambda square, that gives you minus lambda cube plus 2 lambda square, gives you, we will be interchanging signs. So this will get to cancel and this will result you minus 3 lambda square, and this will come down, which gives you plus 16 lambda. Then again I will be multiplying this with minus 3 lambda. Resultant will be minus 3 lambda square plus 6 lambda, and then again interchanging signs. This will be getting cancelled and this will be 10 lambda and this will be going down, gives you minus 20. Now I will multiply this with plus 10. The resultant will be 10 lambda minus 20. By interchanging the signs, the resultant will be 0. So this is the required x of characteristic equation. So the resultant will be lambda minus 2 into minus lambda square minus 3 lambda plus 10 equal to 0. Now let me send this minus towards this side so that solving this equation will be pretty simple. So lambda minus 2 into lambda square plus 3 lambda minus 10 is equal to 0. Is that right? Right. Now by solving this equation, we will be finding out eigenvalues. Lambda square plus 5 lambda minus 2 lambda minus 10 equal to 0. Why I am taking it in this way? To find out factors, because 10 is 5 2's 10, right? So I will be replacing this 3 lambda as 5 lambda minus 2 lambda. Then lambda minus 2 into lambda plus 5 and lambda minus 2 is equal to 0. By this, the factors will be minus 5, 2, 2. As we have discussed the definition of eigenvalues, the eigenvalues can be distinct or non-distinct. As you can see here, 2 is repeated twice. So this is not a distinct value, whereas minus 5 is a distinct one. Now we have to find out the eigenvector. So the resultant obtained values are nothing but eigenvalues. Now to find out eigenvectors, I will be considering lambda 1 as minus 5 and lambda 2 as minus 2. So let us consider lambda 1 as minus 5 and substitute it in the characteristic equation. That is lambda 1 is equal to minus 5, and substituting this in det of a minus lambda I is equal to 0 gives you 3, as we have written earlier. Okay, let me write the characteristic equation first. Minus 5, 4 minus 1 minus lambda minus 5 minus 2 minus 1 minus 3. And this equation will be by substituting minus 5 in this particular lambda. So 3 minus of minus 5, 8, minus 2, minus 5, 4, then minus 1 plus 5, 4 minus 5 minus 2, here it is also lambda, sorry. So minus 2 minus 1, then here it is minus 3 plus 5, that is 2. Now to find the eigenvectors, this particular characteristic equation should be multiplied by x1, x2, x3 and should be equated to a 0 matrix. Now let us find out the equations. 8x1 minus 2x2 minus 5x3 is equal to 0. Let's say equation 1. Then 4x1 plus 4x2 minus 5x3 is equal to 0. Let's say equation 2. Let me stop here first of all so that we will be eliminating one particular equation. I am interchanging the signs. That is simply I am subtracting equation 1 and equation 2. Minus plus, so this will be getting cancelled. So resultant equation will be 4x1 minus 6x2 is equal to 0 implies 2x1 is equal to 3x2, that is equal to x1 by 3 is equal to x2 by 2. Let us consider this equation as 3. Now let us consider the third equation. What is the third equation? Minus 2x2, let me write it. Minus 2x1 minus x2 plus 2x3 is equal to 0. Am I right? Minus 2x1 minus x2 plus 2x3 is equal to 0. Now I'll substitute equation 3, this one, into this equation. That is 2x1 is equal to 3x2. Right, this is the equation 3. Now I'll be substituting it in this particular equation. Let us say this is 4. Now by substituting it, minus 3x2 minus x2 plus 2x3 is equal to 0. Implies minus 4x2 is equal to, plus 2x3 is equal to 0. Implies 4x2 is equal to 2x3, then x2 by 2 is equal to x3 by 4. Let's say equation 5. Now by equation 3, x1 by 3 is equal to x2 by 2, right? So with equations 3 and equation 5, the resultant will be x1 by 3 is equal to x2 by 2 is equal to x3 by 4. Implies the resultant eigenvector for the eigenvalue lambda is equal to minus 4 is that x1 is equal to, let's say, some constant into 3, 2, 4 transpose. So this is the required eigenvector for the lambda value minus 5. Let's say this is one of the equation. So in the similar way, we have to find out the eigenvector for eigenvalue 2. Let's see. Lambda 2 is equal to 2. Now substituting this in the equation of A minus lambda I. Okay. Gives you 3 minus 2 minus 2 minus 5 4 minus 1 minus 2 minus 5 minus 2 minus 1 minus 3 minus 2. So the resultant value will be 1 minus 2 minus 5 4 minus 3 minus 5, then minus 2 minus 1 and then minus 5. Now this particular equation should be multiplied with x1, x2, x3 similar as for the which we found out earlier and should be equated to a 0 matrix. So let's see. x1 minus 2x2 minus 5x3 is equal to 0. Then 4x1 minus 3x2 minus 5x3 is equal to 0. Let's say this is equation 1 and equation 2. Now by subtracting equation 1 by equation 2, the resultant will be, subtracting this one, then minus 3x1 plus x2 is equal to 0 implies 3x1 is equal to x2, that is equal to x1 is equal to x2 by 3. x1 by 1 is equal to x2 by 3. This will be equation 3. Now by solving third equation, then the resultant equation of this particular one. Okay, so minus 2x1 minus x2, then minus 5, right? So minus 5x3 is equal to 0. This will be equation 4. And by equation 3, 3x1 is equal to x2, right? This is equation 3. Now by substituting this particular equation here in place of x2, resultant will be minus 2x1 minus 3x1 minus 5x3 is equal to 0. Then minus 5x1 minus 5x3 is equal to 0. Then this will be getting cancelled. So x1 is equal to minus x3 implies x1 by 1 is equal to x3 by minus 1. This will be equation 5. Now by comparing equation 3 and equation 5, the resultant eigenvector will be, let's say x2 is equal to, consider some constant, into, here the equation, let us consolidate it first, x1 by 1 is equal to x2 by 3 is equal to x3 by minus 1. So here the resultant eigenvectors will be 1, 3, minus 1 transpose. So this is a required eigenvector of eigenvalue lambda is equal to 2. Similar way, we have find out here that the eigenvector of lambda value is equal to minus 5. So this is the procedure of finding out eigenvalues and eigenvectors of required 3 by 3 square matrix. I hope it is clear here. Thank you for watching my content. Please like, do, share, subscribe if you really like my videos. Thank you.